clean this up. So I will have to divide both sides by 5. So I have e to 2x plus 1 equals 8/5. And yes, because the base is e. If the base were 10, I would have applied log. But if the base is e, I will apply natural log. So then I bring 2x plus 1, but it has to be in parentheses. But it doesn't really matter because natural log e is how much?
1.
Thank you very much. Equals natural log of 8/5. Of course, I will subtract 1. So I have 2x equals natural log of 8/5 minus 1, and then divide by 2. So I have natural log of 8/5 minus 1 divided by 2. And yes, if we put this in the graphing calculator, I'm sure everyone got the correct answer. So I have parentheses at the top. Be very careful. Parentheses at the top, natural log of 8/5. Don't forget to subtract 1, close the parentheses, and divide by 2. And with 2 decimal places, this is approximately negative 0.26. And I think everyone got that correctly. Awesome. Great job. Okay, I'd like to, where is my book? Right here. So we're back to page 205. I think we exhausted everything. I just want to look at a word problem so we can move on. So a sample of 5 milligrams, right here, 5 milligrams of the isotope gold 198 decays naturally. This is a radioactive substance, so it decreases its mass in time. It decays naturally. The amount A, which is right here, in milligrams of the sample still remaining after T days, A of T, is given by this formula. This is the same thing with continuously compound interest. It's the exact same formula. So let me just copy that. This is 83. So we have A of T equals 5 e to negative 0.257 T. How much of the 5 milligram sample remains after 1 day? We have to check. T is in days. A is in milligrams. So A in milligrams, T in days. What am I asked to find? What is remaining after 1 day? Part A. What do I have to find? What is remaining after 1 day? What do you think? Anyone, please give it a shot.
I'm sorry, can you say it again?
Yes. We are asked to determine, so this is the amount, function of time. And they're asking us what is the amount remaining after 1 day? Find the amount remaining after 1 day. What do you think? Anyone? Find the amount after 1 day.
A of T when T equals 1.
That's it. Awesome. Back to the graphing calculator. Here it is. So I have 5 e to power negative 0.257 times 1, close, and this is it. So after 1 day, the 5 milligrams, initial 5 milligrams, will turn into 3.8668 milligrams. Perfect. Then, part B. After how many days will only 1 milligram remain? After how many days 1 milligram amount is now 1 milligram? After how many days? How do I do this? What am I asked to do? What is the problem now? Asking now to do.
That it equals to a 1.
Yes, the amount is 1. 5e to negative 0.257t. That's why we solved that. So how do I solve this equation? What is the first step?
You divide both sides by 5.
Yes, 1/5 equals e to negative 0.257t. Awesome. What is the next step? Great job.
Multiply by ln.
Yes, we are applying natural log to both sides. So this is natural log of 1/5, which is a simple number. This is negative 0.257t, and I should write times natural log e. But how much is natural log e?
One.
Exactly. So therefore t equals this over this. Natural log of 1/5 over negative 0.257. And I have to approximate it. Number of days. So here it is, natural log 1 divided by 5, or you can put 0.2, that's fine too. Do not forget parentheses around the denominator because it's a negative number, 0.257, and close the parenthesis. And this is our answer. So we had initially 5 milligrams. After how many days we are going to be left with only 1? After 6.26 days. Okay? After how many days will half of the original amount remain? After how many days will half of it, half of the original amount remain? How do I do that? What is half of the initial? What was the initial? What was the initial amount?
5,
Good. What is half of it?
2.5.
2.5 equals 5e to negative 0.257t. So now we want to determine the time needed for the 5 milligrams to become half, 2.5. Perfect. Okay, so how do I continue? Same process over and over. How do I continue this? First step. Anyone, please?
Divide by 5.
Right. 2.5 divided by 5 is 1/2. Equals e to negative 0.257t. Exactly what we did before. We are applying natural log to both sides. We have natural log 1/2. I bring down negative 0.257t times natural log e, which is 1. So I have t equals this over this again. Same process. So let's see. So if from 5 to 1, it needed 6 days, from 5 to 2.5, it has to be less than 6 days, right? Good. So here's what I'm going to do. I'm just simply going to replace this number by 2. So 2.7. So t approximately 697 if you want the days. Final question. Find the limit of this function as t approaches infinity and explain what this number represents. So we want in part D. limit as t approaches infinity from 5e to negative 0.257t. And let's see what this represents. So remember, when we find a limit, we have to plug it in piece by piece, but I have to start where t is. So if t approaches infinity, where is this going? What is the target of this when t approaches infinity? Negative 0.257 times infinity. Where will this go? What do you think?
Negative infinity.
Absolutely. Thank you so much. Awesome. Now, e to negative infinity. E to negative infinity, as we know, and we have to know this, please, is e to infinity. How big is e to infinity? It's infinity. And we discussed this a long time ago. A tiny number divided by huge. Where is this going? I know everyone knows this. Where is this going?
0.
Thank you very much. So if this piece is going to 0, how much is 5 times 0? You can say it's a silly question.
0.
Yes. So the answer is indeed 0, which makes sense. So the amount, after many, what is time approaches infinite? Doesn't make any sense, right? But after many days, the amount will be close to 0 because it decays. It decreases its mass. Awesome. Very good. Okay, so I think we had enough of this, so we should move on to section 2.2. Section 2.2 deals with derivatives of exponential functions. Derivatives. Basically of e to the x. This book does not really go into detail of a to the x. How do we differentiate this? So I'm not going to torture you with that. We're going to talk about e to the x. E to the x is a very nice function. It turns out that its derivative is itself. You can say, how come? Yep. So when we differentiate e to the x, we get e to the x. To be exact, I should write times the inner function prime. But why don't I write x prime? How much is this? Everyone knows how much is x prime. I know that for sure. Anyone, please? X prime. Please? Any courageous soul to give me x prime? I can't believe we are stuck on x prime. Not possible. Anyone, please? Is anyone with me?
1.
Thank you so much. Thank you for saving me. Good. However, can anyone help with the following? E to a function prime. What do you think this will equal to? And then we'll choose examples. Please. Can anyone give us e to a function prime? What should I write? Exactly what you see here. Anyone would like to try?
E to the function.
Yes, of course. Since it's not x, I have to write it. This is not x. Times?
Mm.
Times what? How do we differentiate a function to the power n? How did we do this? What was the rule for a function raised to a power? We used it on the test, right? We used it so far. What should I write? Anyone, please? Anyone would like to try? No one remembers this from the test or before as a rule? Anyone?
How long goes in front?
So n, f2, f2, which power?
Would it be E?
N minus 1 times the inner function prime. Again, I'm begging you to watch the videos so that this gets embedded in your system, because it's difficult. It's not easy. So obviously e to f times f prime. Exactly the same idea, but e to the function prime is e to the function times f prime. Okay, so that's all we need to discuss in this section. There is nothing else. I'm just going to go directly to the page, which is 210. And let's practice this.